Okay, today we're going to be talking about taking functions and moving them. And we move them 1 point at a time. Does that make sense to you? If I have a function and that function is, oh, let's say it's the square root function. I moved it from where it normally starts. Which way did I move it? It's subtle, but yeah, I moved it to the right just a little bit of where it normally starts. See what I'm saying? So this whole function just moved to the right one. Well, if it was called f of x, then it just moved to the right one. You'd say f of x, and then to the right one, you'd go minus 1. Does that make sense to you? I just took f of x, and then I moved it to the right one. Okay. Now, to do that, a whole bunch of points had to move. Like, there's a point here, there's a point here, there's a point here. All of those points used to be over here, and I just had to move them all. Okay, every point on the function moves when you move the function. All right, so what if I did this? Y equals 3 times x minus 7. I'm going to make it squared. Would you agree that's a parabola that just got moved? Why do I know it's a parabola? Because it's got a squared there, and I know that y equals x squared. I know all those parent graphs. We'll review them in a minute, but that one got moved 7 to the what? 7 to the right, and then, do you guys remember what that is? It's a stretch, very good. That's called a vertical stretch. And this would be 7 to the right. Two things I want to really remind you about. It's horizontal on the inside. It's vertical on the outside. What if I put something over here like a minus 8? Is that on the inside or the outside? Outside, so therefore it's a vertical on the outside. Make sense so far? Do you get that I have one horizontal change and I had 2 vertical changes? Okay. Now, would you agree that there was some point on this original graph, which the original would have been y equals x squared, there would be some point that is the vertex, the lowest spot. Do you remember where it would be on y equals x squared? What's the lowest spot on that? 0, 0. Would you agree 0, 0 was on the original graph? I'm going to teach you how to figure out where 0, 0 moved to when we do that to it. Do you get it moved somewhere? Do you agree it moved to the right 7? Okay. Now it seems like I should take the 0 and subtract 7 from it, to figure out what happened to the x value. Doesn't it seem like I should subtract 7, but what do you actually do? You don't trust the stuff on the inside, remember that? So I don't take 0 minus 7. It isn't at negative 7, comma, something. It's moved to the right 7. So I have to do the opposite of this minus 7, and I had to add 7 to it. So my new point will be 7, comma, and then my y value, well, I'm going to triple this 3 right here. Means, hey, triple whatever you had, and then subtract 8 from it. Do you get from my y value of 0, I would triple it and subtract 8. Can I trust those and just do what it says? Yeah, because it's the y stuff, and the stuff on the outside you can trust. And so it says to triple it and subtract 8. So let's triple it. What's 0 tripled? 0, and then I subtract 8, and I get negative 8. I get that the most common mistake here would be thinking that this was a negative 7. Do you get why it's not a negative 7? Because you can't trust the inside. Seems like you should just take 0 minus 7. Nope. In fact, I did that in my first class. Actually, one of the students did it, and then I didn't catch it because it's so easy to just like trust. It says minus 7, I'll just subtract 7. No, do the opposite of that. Okay, so 0, 0 turned into, the vertex is now not negative 7, 7, comma, negative 8. Now, some of you will remember that because, look at this. This spot here and this spot here contain the vertex because this is called vertex form. You see what I'm talking about? but we always did the opposite of this number in here on the inside because we knew we couldn't trust it. So that's another way to say that the vertex moved. Okay, that's a lot. And that, I just covered a lot, but that's like the meat of what the new stuff is for today. Let's make another one like that and see if you can hang with this, okay? Everybody write this one out. Y equals 5 parentheses 2x end parentheses plus 6. Now, what if I don't even know what the function is? You might be like, what are you talking about? You don't know what the function is. What if this had just been y equals f of x? And then I did all that stuff to it. Well then, I know this is confusing, but they'd just have an f in the middle of the function like that. It'll make more sense if you watch me build it. Do you get if I took y equals f of x, and then I just did a 5 in front of it, because I made it 5 times taller, and then I put a 2 on the inside because I wanted the inside to get stretched or shrunken a little bit, and then I put a plus 6 on the outside. You see how I built that? And it has an f in it because it was some function, and I did those 3 things to it. What did the 5 do to it again? Stretch, vertical stretch. And horizontal on the inside. Here, let me switch colors. Horizontal on the inside and vertical on the outside. The inside stuff, that's the horizontal stuff. And the horizontal stuff seemed like it was twice as big. But can you trust it? No, so it's not twice as big. It's actually half as big. When you put a 2 on the inside, it makes it half as big. Okay, and then this seems like I should move it up 6. And you should, because you can trust the stuff on the outside. And this seems like I should times by 5. And you can, because you can trust the stuff on the outside. So let me just say that there was some point on this function, because I never said what the function was. I know, you got to get used to, like, sometimes you don't know what the function is. You don't know that it's x squared. You don't know that it's the square root of x. You don't know what the function is. Maybe it's just a weird squiggle function. Can we make up a squiggle function? We absolutely can. Here's a function, and I did these things to it. And it got 5 times taller than it used to be, half as wide as it used to be, and then we moved it up 6. So we took this strange looking function and did these things to it. All right. So would you agree that I could say from looking at this graph, this looks to me like 3 comma 2 is on my original function. If 3 comma 2 is on my original function, you just have to trust me on that one. 3 comma 2 is on that original function. Well, then there must be some new point that's beyond the stretched function. And it's not going to be at 3 comma 2 anymore. So here's what you do. You take the x of it, which is this right here. You take that 3, and which part has to do with the x? The inside or the outside? Inside. This is the x part. Horizontal's on the inside. And it seems like I should just take this 3 and double it. So I don't double it. Instead, I cut it in half. And my new point won't be 3 comma 2, of course. It'll change to, well, that 3 doesn't double to 6. It cuts in half, and it becomes 3 over 2. Get how I got that? All right. And then my y of that point, this 2 right here, that does do what it seems. It does times by 5, and it does add 6. So I can take 2 times the 5 is 10, and then add the 6. 10 and the 6 makes 16. There's my new point. 3 over 2, comma 16. Process that for a minute. The x had to do with the inside. The y had to do with the stuff on the outside. And the stuff on the inside, we didn't trust it. Otherwise, that 3 times 2 would have made a 6. This was not a 6 because we didn't trust the stuff on the inside. All right, with that power intro to this lesson, now we're going to step away from it for a minute, let your brain kind of cool, and we'll go back to some old stuff you're supposed to remember. Would you just highlight in green the area where it's increasing? Just take your highlighter on your iPad, highlight in green. Where was it increasing? I hope you picked this area right there. Raise your hand if you highlighted the correct area. Okay, then how would you say it in math? Well, it was increasing from something to something. Somebody be bold and tell me what you think the answer is. Don't be shy. From where to where? Nick, I know you know it. From where to where? You can do this.
-6 to -1.
Yep. From -6 to -1. Remember, these are x values. And for the next bit, it's just constant. The teacher kind of was tilting a little bit when they wrote it, but that area there, that's constant. That doesn't change. It doesn't go up or down. Neil, can you tell me where it was constant, from where to where? Yep. And then the rest of the time it's decreasing. And notice there's even a little arrow at the end that keeps decreasing. Cal, can you do the decreasing part?
Yeah, from 4 to infinity.
You got it. Notice I'm just putting parentheses on this. When you're talking intervals, you don't have to use parentheses. Sorry, you don't have to use brackets. You can just use parentheses the whole time. You could even argue at the moment something stops, is it still increasing? It was increasing, and then all of a sudden it stops. At that moment, is it still increasing? Well, you could kind of argue both sides of that. So I could see why you'd use a bracket or why you wouldn't. But anyway, I wouldn't mark it wrong if you put a bracket. Okay, how about local maximums and local mins? These are just points. Let's all agree that even though it's slightly off of this on the graph, that spot right there and this spot right here are the two high spots. That means that they're local whats? Say it if you know it. Local maximums. Okay, and then only one of them would have been the absolute maximum. But then a kid noticed that this down here curls up. Do you get how that implies? That if we continued to draw it, it would go like that and keep going up forever? So there actually is no absolute maximum. It seemed like this was going to be it. But the fact that it was headed back up down here means that there is no max. No absolute max. So those two are just local maxes. All right, everybody put a red dot where the local min is. How did I say that wrong, Neil? I said put the red dot where the local min is. Did you put a dot here? There's two local mins. That's what I'm trying to say. There's two. There wasn't just one local min. There was two. Is there any absolute minimum? No, because did you see the other side was still going down? So those two are low spots. They're both local mins, but neither one of them is an absolute min. So do you, this is a good question I got on the other hour, and I just want to ask it. So is the absolute minimum negative infinity? Well, you have two choices. How many of you would pick, if you were asked, what is the absolute minimum? Is the absolute minimum negative infinity? Or is it that there's no minimum? We get that this thing goes down, right? Keeps going down, and it will go down to negative infinity. But what should we say then? For the absolute min, is it negative infinity or there is no absolute min? Raise your hand for there is no absolute min. That is the correct answer. Good job. You don't say it's negative infinity. You say there is no absolute min. And again, I get how this could be argued, but there's really, in this one, there is a right answer. You shouldn't say the minimum is negative infinity because you're implying that's a place. Minimums and maximums are a place. And negative infinity is a concept. It's not a place. All right. Moving on. Your quiz that you have tomorrow has some of these on it. I know that you guys did 9 days off, but I know that most of these were super easy before. But I'd like you to look through it and ask if you're not sure on one. Because in my last hour, they were honest. Once they knew that they had a quiz on it, they asked on about 6 of them. So I know there's some of these you don't know how to do. So just raise your hand and be honest and say, yeah, I'm not sure how to do number 46 or whatever. I know some of these are pretty easy. All right, to get you talking to the people next to you, what I'd like you to do is I'd like you to highlight at least 3 or 4, maybe it's more, however many, of these you think you're going to get wrong if I give you the quiz right this second. Which are the ones you think you'd get wrong? And then I'm going to just ask you to compare your list with the kid next to you. And we'll see which one of you guys all agree that, oh, yeah, number 44, I don't get how to do that. I don't remember that. Or maybe it's number 45. Maybe it's number 51. Okay. Highlight your top at least 4 that you think you might get wrong tomorrow, and then we'll compare. Back to recording again. The domain. That one was pretty easy. I'm guessing wasn't too many people that needed to know that. It's from here to there. So -5 to 3. Good on domain? So how many of you want to know, we're just going to do a quick hands up thing. How many of you want to know about, and I'm going to read off a whole bunch of numbers, okay? So be ready to raise your hand for the ones that you need. Who needs number 44? Who needs number 46? We're going down that column. Who needs number 48? There's a bunch of people on that one. Okay. Who needs number 50? Number 52. Number 54. Number 56. Number 43. Now we're in the other column. Okay, that was enough, I think, to do number 43. Number 45. Number 47. Number 49. Lots of people. Okay. Number 51. Lots of people. Number 53. Number 55. Number 57. Okay, now there's a few hands for other ones, and I will be happy. You just have to ask it again in a second. I'll be happy to answer the other ones too, but I got to answer these 4 because that's what the vast majority of the class needed. Find the zeros of F. If I just said the x-intercepts, would that be easier? So you better write down that a 0 is an x-intercept because it's the same exact thing. The zeros are the x-intercepts. Do you get that there's 3 of them? There, there, and there. And you can say x equals -4. You can also say it as an x-intercept where y equals 0, so you had -4, 0. And you think that's why they're called 0? Yeah. That's why they're called zeros, because the x-intercept, -4, 0, is what makes y equal to 0. It's the x-intercept. That's one of them, and there's 3 of them, okay? All right, on to the range. For the range, you want the lowest to the highest. So what's the lowest this function ever went? It was down here. And what's the highest that this function ever went? It was up here. Now, I know you get used to looking at both ends of the graph, but that's, in this case, not the case. That's the lowest it went. That's the highest it went. So what was the range? From -5 to 4. A way to think of the range is it goes like this. Right on the y-axis, the lowest it went to the highest it went. Yes? All right, so the range depends on whether you touched it or not. Do you feel like it hits 4 for a height? I agree. Do you feel like it hits -5? Yes, so you'd use brackets on that. So my range would be, final answer, from -5 to 4. More questions on the range? Okay, how about f of x is greater than or equal to 0? Whenever you see f of x, you can either replace that with the word the function. So when is the function bigger than or equal to 0? Or if that isn't working for you, you can say when is y, because f of x is like y, right? When is y greater than or equal to 0? Well, it's in here. Would you agree that whole time y was bigger than 0 or equal to 0? So how would we say that part? From -4 to -1, and it touches, it works, it's included because it's or equal to 0. Is there another area of the function where it's greater than or equal to 0? I'll do it in red. Everybody write the answer for this part. That part's above 0. So Gio, how do I write that?
Writing a range of...
I didn't mean to catch you off guard. I'm just, this part, this blue part we just did here, and there was another part, this red part, where the function was above 0. If you can do it quick, great. Otherwise, just pay attention from here. Jake Cannon, can you do the red part?
1 to 3 in brackets.
From 1 to 3, it was above 0. And brackets, and does it actually touch?
Oh, no, it doesn't.
So let me think though. Does the function, is the function above 0 there? Yes, it is. So I know that's confusing, but you'd have brackets on both ends. It's not equal to 0 at 3, but the function is above 0 at 3. So it's good. On this, yeah, so they brackets on both ends. Okay, and then the last one people wanted to know about odd, even, or neither. This one is a neither. But, in case you were wondering, what if the function had looked like this? Do you guys remember that function? That one is odd function. And separately, it's got a certain kind of symmetry. Do you remember the name of the symmetry it's got? Odd goes with another O word. Origin. Origin symmetry. Because if you go through the origin and you pop out the other side, there'll be another point that goes with it. See? Like if this has the point 2, 8 on it, this will have the point -2, -8. And I know I didn't graph this beautifully to make that work right, but the numbers would be exact opposites of each other. All right, if I pick a point here and I go through the origin, wait a minute, that's not a point on the graph. This is a point on the graph. And I go right through the origin, there'll be another point exactly on the other side of that. I didn't do the points far enough away from each other. All right, anyway, let's get on to even functions. That's an even one. And it's got a certain kind of symmetry. Y-axis symmetry, good. That's an even one. So if I go straight across the y-axis, instead of straight across through the origin, if I go straight across the y-axis, there'll be another point there. And so this is the point 2, 4 on a normal parabola, then this would be the point -2, 4. And then that brings up, what if something is like part even symmetry and then part like, I don't know, some other origin symmetry or something? What's that one? Even or odd? Neither. That's not even and that's not odd. Okay, here's some more obscure ones. Is that one even or odd? That one's even. Why? Because it has y-axis symmetry. Is that one even? Nope, it's got x-axis symmetry. That's different. Is that one odd? Nope. This would be an example of an odd one. Would have origin symmetry. Well, how do I know this one doesn't have origin symmetry? Well, I could take a dot and I can go through the origin and look out the other side. Is there another dot over there that goes with it? No, it doesn't have origin symmetry. So it doesn't have origin symmetry and it doesn't have y-axis symmetry. There was no point over there either. So this one's not even or odd. It's to neither. And then just side note, we don't have to do these today, but this is one of the rules. This is the other rule. And it starts exactly the same, but it has a negative here. Oh, that's odd. Ooh, that one's the rule for odd. Take a wild guess what the blue one is. The rule for evens. We will review that later. You knew it 9 days ago, but you don't have to know it yet. This is only day 2 of the unit. Okay, so those are two that you remember you stick in negative x into the function and you see what happens. And if you get the original function back, it was an even. And if you get the opposite of the function, it was an odd. All right. Now let's just everybody make a quick sketch of all the parent functions. There are 6 of them. And I know you probably don't know the last one. This is the cube root function. I didn't even remember what it looked like. So what I did is I made an XY chart, found a few points. Then I was like, oh, that makes sense. Once you see it, it'll make sense. So remember, if you get stuck on any of these, make an XY chart. If you get stuck on the first one, I'm going to be disappointed. It was that, etc. But if you have to make an XY chart because you're like, I don't remember that one, then you just stick in 0 and you see what you get. And you get 0 to the third is 0. Okay. 1. 1 to the third is 1. Okay. Well, 0, 0, and 1, 1 are on a lot of the functions. Maybe you should stick in like 2. And then I got 2 to the third is 8. Oh, 2 comma 8's on this. Oh, I remember this one. See what I mean? So if you ever get stuck, make an XY chart. I'll pause for a minute while you find all 6 of them. Okay, hopefully these came back fairly quickly. That's the x to the third function. The square root function kind of looks like that. The absolute value function is a V shape. 1 over x function, it would take a while to make enough dots before you would realize it's that one. Remember how it's got asymptotes, so it never touches the x or the y-axis? How many of you had that one? I'm curious. It's about half of you. All right. And last but not least, this one. So as I was saying, you'd probably have to make an XY chart. You'd stick in 0 and you'd say, what's the cube root of 0? Well, 0 times 0 times 0 is 0, so it's 0, 0. And I put in a 1. Cube root of 1. 1 times 1, it's 1. What's the next cube root that works out nice? 8. Cube root of 8 is 2, because 2 times 2 times 2 makes 8. So 8 comma 2. 1, 2, 3, 4, 5, 6, 7, 8. It's off the graph just a smidge. There's 8 comma 2. And then 0, 0, and 1, 1. Oh, it's when you put in negatives, you'd realize it's like that. It's kind of like the x to the third graph, except it's like turned sideways. All right. So do you get if we give you this graph and then say plus 1, and then we asked you for the range of it, we'd expect you to be able to do that? So you'd be asking yourself, okay, well, the original one looks like this, and then I move it up 1, and then I'm asked for the range. Well, the range still goes down forever and up forever, so the range would be negative infinity to positive infinity. Does that make sense to you? How about the domain of it? How far left and right does it go? Infinity. So the answer is negative infinity, positive infinity. So the domain and range of this is goes forever in all directions. Yay. This is a better one for doing domain and range on. Domain of these is always negative infinity and positive infinity. But the range does vary a lot. All right. Good enough on that. Now, I don't like this one that much because it's kind of vague. So instead, I'd rather do this on a more specific example. So I'm going to give you, I'd like you to just cross this off. And next to it, I will write 4 times f of x. Notice I'm putting that in black. And then I'm going to say minus 2. And then I'm going to say plus 6. Do you get what they're trying to say here is I've got a function, f of x, and it's been moved in 3 ways. This is the a. And what is that 4 doing to the function? Remember high vo. Horizontal on the inside, vertical on the outside. This would be a vertical stretch. What if I'd said 1/4? Then it wouldn't have been a stretch, it would have been a shrink. Okay, how about the B? That's this guy. Actually, it's what number's in front of the X. Would you agree that there's a 1? If there's nothing else, there's a 1 there. So the B, in this case, the horizontal stretch was 1. A stretch of 1 doesn't really do anything, does it? No. And how about this is the C, and what would it do? It would go right to. Remember, we can't trust the stuff on the inside. And the D is that. And it seems like up 6, and it is up 6. Because you can trust the stuff on the outside. All right. What does high vo mean? Braden, what does the high stand for?
Horizontal on the inside.
Horizontal on the inside. Good. Let me ask you a tougher question, Braden. Which of them is affected by horizontal? The X values or the Y values? Which ones do the horizontal thing? Think on the graph. Here's which way you go to go X. Here's which way to go Y. This is horizontal. It's like the horizon line. The horizontal goes with X. Okay. All right. So then when we get this, we just did one just like this. I hope this is easier for you. What's happening to the X here? This part. That's what's happening to the X. And what's happening to the Y? This stuff. The vo stuff. Vertical stretch and an up 6. On the X, it seems like we should times by 3 and subtract 4. But that's not what we'd actually do. We would go right 4, and we'd also make it 1/3 as wide. Because of this 3 here. It seems like it should be 3 times bigger. Stretch 3 times. Can't trust it. 1/3 as big. 1/3 as wide means it's shrunk a lot. All right. So here's the big moment where I was trying to get you to at the very beginning of the hour, and let's see if you got a short-term memory. This point, 5, 8, was on the original function. This is the x part, and it'd be really easy to think I'm going to take my 5 and times it by 3 and subtract 4. But you can't trust that. And so here's the easy way. Instead of going, okay, I know I've got to divide by 3 instead of times by 3, and I got to add 4 instead of subtract 4, you could do that, but then you got to do it in the right order too. So here's the best way to do this. Everybody write this out. 5 is equal to the 3x minus 4. And I want you to think about why that makes sense. Just write out 5 equals 3x minus 4. Why does that make sense? Because this right here, I'm going to highlight it. That is where x would have been. If we had said f of x, that's where x would have been, right? That's the x part. The x part is that. X is that. And now do you get, it'll make me do it in the opposite order and it'll make me do the opposite thing? Because if I'm solving this, I'm going to add 4 to both sides, see? And I won't take my 5 and subtract 4. I will add 4 to my 5. And it'll make it 9 equals 3x. And then I won't times it by 3. I will divide it by 3. And x will be equal to 3. All right. I hope you get how the stuff on the inside is what we do to it, but we don't do what it seems. It seems like times by 3 and subtract 4, but instead it's add 4 and divide by 3. All right, and now let's get the y. Would you agree the y starts as 8? So where should I put that? If this is f of x, would you agree that what I just scribbled out is supposed to be the x? You know, if I was going to say f of x, it says f, and then it says all that stuff. That's where f of x would be. So all of this is f of x, and f of x is the 8. So you put the 8 right here. Another way to say it would be, do you get we got to times by 5 and add 6, and we can trust it? The two things that are on the outside are times 5 and add 6. And we can trust them. So we just go 5 times the 8 and then add 6. 46. So you scribble out the inside, the f of x part, and you put the y value there because y is f of x. All right, if you really caught that, go to this one. I got my x, I got my y. Geo, which one's the x?
X is 14.
And the 14 goes with which part of this black function here?
If you write in parentheses 6x minus 4.
6x minus 4 is equal to 14. And then you solve. I know you can all solve that. That's the easy part. Just try to remember you set the inside. That is the x. Another way to say that is, I scribbled it out right there. That thing I just scribbled out, that's the x. X is all that. And now, if I scribble out f of x, that's where f of x was. That whole thing. And that's where you'd put, which one of the things is f of x? If you haven't figured this out, this is so critical. This is x and this is f of x. F of x is 8. So that's 8. So it's 14 minus 2 times 8. So it's 14 minus 16. So it's negative 2. There's my new point. Oh, wait, it's not 14. Sorry. I got to add 4 to solve this one. 6x equals 18. x equals 3, and y equals -2, 3 comma -2 is what that would turn into. How many of you got that one right? I'm up to most of you. One last one. All right, so the x value. L, can you tell me how to take this 1 and do something to it to get my answer? Nice, because that part right there is where the x would be, and x is 1. I like it. And then what do I do? Nice. Negative x equals -2. X equals 2. Raise your hand if you had x equals 2. Nice. And the new y value. Olivia, can you explain how to do that one?
You multiply -8.
All right.
And then you add 10.
All right. So I'm going to take, actually, let's actually do it then. I'm going to scribble out this part. And you said to multiply it by -8. What goes in the red area? The thing I just scribbled out? The 2. So then what do I get?
-16.
-16 plus 10?
-6.
-6. So my point is 2 and -6, 2 comma -6. Raise your hand if you had that one right. Good job. All right. This looks super scary, but what if I told you it's the exact same thing? It's just that they gave you 5 points. Now we're running out of time, so I don't want to do all 5 points. And this is identical to this. They're the same thing. Don't stress about that. But would you just take the first point there? -4, -3, and figure out what the new x and the new y would be for that point. And then you just have to rinse, lather, rinse, and repeat. You guys know, right, that you don't have to actually, like it says on all the shampoo bottles, lather, rinse, and repeat. It's a public service announcement. The shampoo companies would like it if you would always wash your hair twice. Run out of shampoo for twice as fast that way. Have to buy more. And I know some of you with super long, bushy hair, super dirty hair, yeah, you might want to do it twice. But. All right, for this, you will have to repeat 1, 2, 3, 4, 5 more times if you wanted to finish this problem. But then you'd know where this new graph would be. Owen, what did you get for the x part? And I hope you used the -4 with the inside here and said -4 equals 1 minus 2x. All right, you go ahead and finish that then. And Jay Cannon, can you tell me how to do the y part? Which is the -3 here. Where does that go? I agree, so I'm going to replace all of that, the part I'm scribbling out in blue, and Owen, if you need it, it's over here. I'm replacing that with what, Jake? So tell me what to do. And that makes? And then the 4? No. You used the negative already. If you're going to say that's +9, then it's 4 plus the 9.
14?
Yep.
Yep. And then it's 13.
13 over 2 is the correct answer. And you might have thought you were wrong because it didn't come out to a nice whole number, but I get it. All right, and Owen, are you done with this part?
Yeah, I got 2.5.
All right, subtracted 1 from both sides, and that would be negative 5. And then you have equals negative 2x. The negatives do cancel, and you get 2.5. Nice job. Otherwise known as 5 over 2. And that's kind of gross. Yes, you just have to repeat that 4 more times, and you got your 5 total points. We're not doing that right now because it just takes too long. It's kind of tedious. Let's move on to the actual homework and show you that. We already talked through this stuff. And we already talked through that stuff. And here's a typical point. They give you this 1 point, and they ask you to do, man, these are super easy. Yeah, we were doing really hard, like R3 level questions. You can make these super easy. Okay, so maybe you should just do 3 of them. I guess I'm going to recommend that you do 2, 5, and 8. There's no magic to that. You don't have to do all of these. Once you get the idea of how these work, and if you're not doing it right, or you're not sure, you should go check the answer. On this page, well, you definitely want to graph the parent one. Got to be good at that. And that's just going to ask you to move it down 1, right 1, and maybe this. Maybe you should just do this 4th one. Just do the double. Move it 3 to the left and down 2. Remember, you can do all of these. There's nothing wrong with these problems. I'm just trying to cut it down to a reasonable size, but I think it'd be good for you. On this page, I know this is kind of confusing how it's laid out. First off, let's just scribble off this whole right side. Next, I would circle this and write parent. That's the parent graph, like the parent function. And it's this weird little function. We call it f of x because we don't really know what it is. It's not like y equals absolute value of x. It's just some little function. We call it f of x. And then you're supposed to do this to it. I'm going to circle this one in blue. And maybe let's do this one that I'm circling in black. And that's going to move the function 2 spots down. You'll catch on to which one changes then, whether it's the x or the y. You know, when you move this whole thing down 2, you'll have to figure out, which of each point, which part should change. So you should probably do one that's moved up, down, and one that's moved left, right. So I think if you did 29 and 30, you'd be good. And maybe just one last one. These are all identical parent functions, so you only really need one of them. So maybe you should do that last one, number 35. Take that parent function and move it like it says. All right. Can I make you do homework? Nope. Can't make you do anything. Can't even make you come to school tomorrow. If you're 16, you can get mom and dad to sign off. Don't even have to go to school anymore. So it should be about you wanting to learn how to do this stuff. And then the test is coming up. You want to be able to show me that you know how to do it on the test. So I recommend doing all the ones I just suggested there. And I do want to warn you that we have a little quiz in class tomorrow. And it's going to be reviewing not the stuff I just taught you, but the stuff that I taught you right before break. The increasing, decreasing, local mins, local maxes, X-intercepts, those kinds of things. Okay, so if you want to go over those ones at the very beginning of the notes there, that's on the little quiz tomorrow. And that's all I got for you for today.